Have you ever wondered about the significance of comets in our solar system? Comets, those icy celestial bodies that streak across our night sky, are not merely beautiful spectacles. They hold within their icy cores secrets about the early solar system and the building blocks of life. For centuries, these cosmic nomads have inspired awe and fascination, from ancient civilizations who saw them as harbingers of doom to modern scientists who view them as cosmic time capsules. Comets have played a significant role in shaping our understanding of the universe. They have been the subject of myths and legends, have inspired poets and writers, and have even led to groundbreaking scientific discoveries. Meanwhile, their periodic appearances in our sky serve as a reminder of our place in the grand scheme of the cosmos. So, if you're ready to embark on a journey of cosmic proportions, let's delve into the fascinating world of comets. Comets, these celestial bodies of ice and dust, where do they come from? Let's dive into the formation and origin of these fascinating objects in our cosmos. The story of comets begins in the early days of the solar system, about 4.5 billion years ago. During this time, the sun and planets were still forming from a rotating disk of gas and dust, known as the protoplanetary disk. Amidst this chaos, comets began to take shape. They are essentially frozen leftovers from this era, a mixture of water ice, other frozen gases, dust, and rocky material that didn't make it into the planets or the sun. Now, where do these icy relics reside? Most of them live far beyond the orbits of the planets in two distant regions of the solar system known as the Kuiper Belt and the Oort cloud. The Kuiper Belt, a wide band of icy bodies, extends just beyond the orbit of Neptune. It's the home of many short-period comets, those that complete their orbits in less than 200 years. But beyond the Kuiper Belt, there lies an even more distant reservoir, the Oort cloud. This is a giant spherical shell that surrounds the solar system. It's so far away that it extends almost halfway to the nearest star. The Oort cloud is believed to be the birthplace of long-period comets, those that take more than 200 years to orbit the sun. When a comet from these distant regions gets nudged by a passing star or the gravitational pull of the giant planets, it begins a long inward journey towards the sun. As it gets closer, the heat of the sun causes the ices in the comet to vaporize, creating a glowing coma and tail that we see from Earth. So, that's how comets come to be. But what are they made up of? Well, we'll dive into the anatomy of a comet in the next part of our journey through the cosmos. At first glance, a comet may seem like a simple object, just a bright light streaking across the night sky. But there is much more to these celestial bodies than meets the eye. Comets are made up of several distinct components, each playing a unique role in the comet's appearance and behavior. Let's start with the nucleus, the solid core of the comet. This is the heart of the comet, the part that houses all the material from which the comet is made. The nucleus is typically a few kilometers across and is composed of a mixture of ice, dust, and organic compounds. The ice in a comet's nucleus is not just water ice, but also includes other volatile compounds like carbon dioxide, methane, and ammonia. These ices are mixed with dust, which contains silicates and other minerals, and organic compounds, which are complex molecules made up of carbon, hydrogen, nitrogen, and oxygen. The nucleus is often referred to as a dirty snowball or an icy dirt ball, depending on the relative amounts of ices and dust. The dirty snowball model suggests a higher percentage of ices, while the icy dirt ball model suggests a higher percentage of dust and rock. As a comet approaches the sun, the heat causes the ices in the nucleus to sublimate, turning directly from a solid to a gas. This creates a cloud of gas and dust around the nucleus, known as the coma. The coma can become incredibly large, sometimes even larger than the sun itself. But the most recognizable feature of a comet is its tail. As the comet gets closer to the sun, the increased heat and solar radiation pressure push the gas and dust in the coma away from the sun, creating a tail that always points away from the sun, regardless of the direction the comet is moving in. And within this nucleus lies an array of interesting components. Each component, from the nucleus to the tail, plays a crucial role in shaping our understanding of these intriguing celestial objects. The nucleus of a comet, a treasure trove of cosmic ingredients, is a marvel to explore. This icy core, often compared to a dirty snowball, is the heart of a comet. It's where the magic begins, a concoction of elements that have journeyed through space for billions of years. The nucleus is primarily composed of two types of ice, water ice and volatile ices. Water ice forms the bulk of the nucleus, while volatile ices such as carbon dioxide, methane, and ammonia make up a smaller yet significant portion. As the comet travels closer to the sun, these ices sublime, going directly from a solid to a gas and giving rise to the comet's distinct characteristics. But the nucleus is not just a block of ice. Embedded within this icy framework is a mixture of dust and rocky material. This dust is not like the dust you find under your bed. Instead, it's a collection of silicate and carbonaceous particles, microscopic remnants from the early solar system. Then there's the organic material, complex molecules that contain carbon, hydrogen, oxygen, and nitrogen. Some of these organic compounds are quite familiar to us, like methanol, ethanol, and even formaldehyde. Others are more complex, like amino acids, the building blocks of life. The presence of these molecules in a comet's nucleus provides tantalizing hints about the origins of life on Earth. And let's not forget about the minerals. Comets are old, really old. They date back to the formation of the solar system, and thus they carry within their nuclei primitive minerals that haven't changed much over the past 4.5 billion years. These minerals provide a snapshot of the conditions present during the early days of our solar system. In essence, the nucleus of a comet is like a time capsule, preserving a record of our cosmic history. It's a complex mix of ices, dust, organic compounds, and minerals, all interacting in fascinating ways. This rich blend of ingredients makes the nucleus a dynamic and intriguing part of a comet. From the nucleus, a glowing atmosphere emerges as the comet nears the sun. As a comet approaches the sun, an incredible transformation takes place. The ice within the comet's nucleus, hidden away for potentially billions of years, begins to heat up. This heat prompts a fascinating metamorphosis, transforming the once frozen world into a vibrant spectacle of light and color. This transformation is the birth of the coma, a glowing atmosphere that envelops the nucleus. The coma, a cloud of gas and dust, is formed by the sublime interplay of heat and ice. As the sun's warmth reaches the comet, it causes the ice within the nucleus to sublime. That's right, it transitions directly from a solid to a gas, bypassing the liquid phase. This gas then expands outward, carrying along dust particles, creating a shroud around the nucleus. What's fascinating about the coma is its size. It can expand to over 1 million kilometers in diameter, making it larger than the sun itself. Following the coma, we often see a comet's most distinct feature, its tail. A comet's tail, a spectacular celestial display, but did you know there's more than one type? That's right, the gleaming trails that follow these cosmic travelers as they journey through the solar system are not all the same. There are two main types of comet tails, the ion tail and the dust tail. Let's start with the ion tail. As a comet approaches the sun, the heat causes the icy nucleus to vaporize, releasing a cloud of gas and dust known as the coma. The sun's radiation ionizes the gases in the coma, and this ionized gas or plasma forms the ion tail. But here's the fascinating part. The ion tail always points away from the sun, regardless of the direction the comet is traveling in. This is because the ion tail is strongly influenced by the solar wind, a stream of charged particles continuously ejected from the sun. Now let's move on to the dust tail. This tail is made up of tiny dust particles that are pushed away from the comet's nucleus by the pressure of sunlight. Unlike the ion tail, the dust tail doesn't strictly point away from the sun. Instead, it trails behind the comet along its path of travel, forming a curved trajectory. This is why the dust tail often appears broader and more diffuse than the ion tail. So, the next time you gaze up at a comet in the night sky, remember that the dazzling spectacle of its tail is a complex interplay of light, heat, solar wind, and cosmic dust. The formation of these tails is a testament to the dynamic and ever-changing nature of our solar system. And these comets, with their distinctive tails, traverse the solar system in unique orbits. Comets on their celestial journeys follow some fascinating paths. These paths or orbits are shaped by the powerful gravitational forces of the planets they encounter. A comet's orbit can be long and stretched out, or it can be more circular, depending on its interactions with these celestial bodies. There are two main types of comet orbits, short period and long period. Short period comets have orbits that take them around the sun in less than 200 years. These orbits remain relatively close to the plane of the solar system. Famous short-period comets include Halley's Comet, which graces our skies once every 76 years. On the other hand, long-period comets have orbits that can take them far beyond the outer planets, into the depths of the solar system. These comets take more than 200 years to complete their orbits. The orbits of long-period comets can be highly inclined to the plane of the solar system, sending them over and under the orbits of the planets. Throughout history, these orbits have brought some notable comets into view. Over the centuries, mankind has been graced with the sight of some truly remarkable comets crossing our night sky. These celestial snowballs hurtling through space have left an indelible mark not only on our atmosphere, but also on our culture and scientific understanding. Let's take a cosmic journey back in time to some of the most famous comets in history. Our first stop is the 4th century BC with Aristotle's comet. This comet was a significant marker in the history of astronomy, as Aristotle was the first to realize that comets were not atmospheric phenomena, but rather celestial bodies far beyond the Earth. Fast forward to the 11th century, and we encounter Halley's Comet. Named after Edmund Halley, the English astronomer who accurately predicted its return, this comet is arguably the most famous of all. Halley's Comet has a relatively short orbital period of about 76 years, making it a once or twice in a lifetime event. Its last appearance was in 1986, and it's set to return mid-century, in 2061. We also can't forget about Comet Hale-Bopp, one of the most widely observed comets of the 20th century. Discovered independently by Alan Hale and Thomas Bopp in 1995, this comet was visible to the naked eye for a record-breaking 18 months. Then there's Comet Shoemaker-Levy 9, famous for its spectacular collision with Jupiter in 1994. This event provided invaluable insights into the nature of comets and the atmosphere of Jupiter. And finally, we have Comet Neowise, a recent visitor that adorned our skies in the summer of 2020. This comet, with its stunning double tail, was one of the few bright spots in an otherwise challenging year. But our fascination with these celestial travelers doesn't stop at mere observation. We've gone one step further, and we've even sent spacecraft to study these celestial travelers up close. From Halley's Comet to Comet 67P, our quest for knowledge has taken us to the doorstep of these cosmic entities. Over the years, we've launched a number of ambitious space missions, all with a singular objective: to study comets up close and personal. These missions have been imperative in feeding our insatiable curiosity and have provided us with invaluable insights into these celestial bodies. The first successful mission to a comet was NASA's Ice and Dust Experiment, or ICE, back in 1986. It was a historic moment, marking our first encounter with a comet, in this case, the famous Halley's Comet. The data gathered from this mission shed light on the nature of cometary nuclei and their interaction with the solar wind. Fast forward to the 21st century, and we find the European Space Agency's Rosetta mission making headlines. Launched in 2004, it reached the Comet 67P/Churyumov-Gerasimenko 10 years later. It wasn't just a flyby. Rosetta actually orbited the comet for over 2 years, studying its composition and structure in detail. The mission even deployed a lander, Philae, marking the first successful landing on a comet. The data from Rosetta has revolutionized our understanding of comets. We now know that comets contain complex organic molecules, the building blocks of life. These discoveries have led to fascinating theories about the role of comets in seeding life on Earth. NASA's Stardust mission, too, is worth mentioning. It collected samples from the comet Wild 2 and returned them to Earth, providing us with tangible pieces of a comet for the first time. These missions have given us a great deal of insight into the role of comets in our solar system. They've shown us that comets are not just relics from the early solar system, but they may also have played a significant role in the formation of life. As we continue to explore these celestial wanderers, who knows what other secrets we might uncover? Comets, while small, play a significant role in our understanding of the solar system. These icy bodies, often referred to as dirty snowballs, are remnants from the formation of the solar system. They are composed primarily of ice and rock, and as such, provide a window into the early days of our celestial neighborhood. Comets are believed to originate from two distant regions of the solar system, the Kuiper Belt and the Oort cloud. These areas, located beyond the orbit of Neptune, are like cosmic freezers, preserving the original building blocks of the solar system. When a comet's orbit brings it close to the sun, the heat causes the ice within the comet to vaporize, creating a glowing coma, and often, a tail. This spectacle gives us a glimpse into the past, shedding light on the ingredients that led to the formation of planets. Moreover, Comets have been instrumental in shaping the solar system. It's widely believed that comets could have delivered water to the early Earth, contributing to the development of oceans. Additionally, comets might have played a role in seeding our planet with the necessary organic compounds for life to begin. Thus, studying comets provides clues not only about the early solar system, but also about the origins of life itself. Comets also contribute to the dynamic nature of the solar system. Their interactions with the giant planets can lead to alterations in their orbits, sometimes catapulting them out of the solar system entirely or sending them on a collision course with the inner planets. And yet, these fascinating objects can also pose potential threats to our planet. The beauty of a comet streaking across the sky belies a potential threat. Comets, while breathtaking, have the potential to cause catastrophic impacts on Earth. History has shown us this, with the Chicxulub impactor, believed to be a comet or asteroid, that struck Earth some 66 million years ago, leading to mass extinction, including the dinosaurs. Today, scientists and space agencies worldwide are working tirelessly to identify and track these celestial bodies. This is to ensure that we're not caught off guard should one head our way. Measures for planetary defense are continually being developed, like NASA's DART mission, aimed at testing our ability to deflect a threatening asteroid. While the thought of a comet impact may be unsettling, it's worth noting that such events are extremely rare. Despite this, the study of comets continues to provide us with invaluable insights. Our journey through the life of a comet has taken us from their formation to their potential impacts on Earth. We've delved into the icy core of these celestial travelers, exploring their intricate anatomy from nucleus to tail. We've discovered the diversity of their components, from ice and dust to organic compounds, all contributing to the luminous spectacle we observe from our planet. We've journeyed through the Kuiper Belt and the Oort cloud, the cradles of these cosmic voyagers. We've learned about their eccentric orbits, influenced by the gravitational ballet of our solar system. We've revisited some of the most famous comets in history, their tales intertwined with our own. We've embarked on ambitious space missions, seeking to decode the secrets locked within these icy messengers from the dawn of our solar system. As we continue to explore the cosmos, comets remain a fascinating and vital part of our understanding of the universe.